Good morning, everyone. Myself, D. Rajitha. I'm working as assistant professor in the Department of Electronics and Communication Engineering and in the College of Mlritm. Today, we are going to learn about pulse radar system and continuous wave radar system. The radar means radio detection and ranging. The radar system is a advanced electronic system. This advanced electronic system uses the modern radio wave technology. By using this modern radio wave technology, we can easily determine the range of the target and the directions and measure the distance and velocity of the target with respect to their locations. The radar systems are known for their accuracy in measurement. Today, these systems are playing important role in various fields. They are weather forecasting, space exploration, military applications, and traffic control, etc. The radar system works by transmitting electromagnetic waves and analyzing their reflections. Historically, the radar systems are developed during the military applications and during the World War II. The modern radar systems are being used along with the advanced technologies like digital signal processing, machine learning, and artificial intelligence. By using these technologies, we can find the easily directions of the antenna and range of the target. This figure shows the basic principle of a radar system. In this, we are using the single antenna for transmission and as well as for reception purpose. By using the duplexer, we can connect the antenna to the transmission section or receiver section. Alternatively, if the duplexer connects the antenna to the transmission section, we can transmit the electromagnetic waves into the space. If the duplexer connects the antenna to the receiver section, then they receive the echo signal from the space. So, by using the transmitting antenna, we can transmit the transmitted signal into the space, and these electromagnetic waves are reflected back from the target in the form of the echo signals. These echo signals are received by the receiving antenna. After receiving the echo signals, these signals are applied to the display unit. Generally, the display units are cathode ray tubes, means CRT. By using these display units, we can easily find out the directions of the target and range of the target. We know whenever an electromagnetic wave is transmitted by the system, then it reflects or re-radiates some of its parts and experiencing a variation in the conductivity of the medium. The variation in the conductivity arises due to the presence of the object, either the stationary or moving objects, thereby producing an echo. The radar system receives the echo by the help of the receiving antenna in order to analyze it and have the location of the object, whether the object is stationary or moving object. The types of the radar system: depending on the scanning pattern, configuration, and application, the radar systems are listed into various types. Some of the common types of the radar systems are monostatic radar system, bistatic radar system, pulse radar system, continuous wave radar system, passive radar system, Doppler radar system, and monopulse radar system. The monostatic radar system. The monostatic radar system means it uses the single antenna for both purpose, for transmission as well as for the reception purpose. By using the transmitting antenna, we transmit the electromagnetic waves into the space. These electromagnetic waves are reflected back from the target as in the form of the echoes. These echoes are given to the display unit. By using the display unit, we can easily find out the direction of the target and the range of the target. So, these radar systems are mainly used in applications like air traffic control, monitoring weather conditions, surveillance, etc. And the next one is bistatic radar system. In bistatic radar system, we are using the separate antennas for transmission purpose and the receiver purpose. The distance between the transmitter and receiver is kept equivalent to the expected distance from the targeted object. This radar system is mainly used in long range, military, and weather related applications. And next one is pulse radar. The pulse radar means the radar system which operates by using the pulses to detect the stationary objects or stationary targets is called the pulse radar system. In pulse radar system, we are using only single antenna for transmission purpose as well as for reception purpose. This diagram shows the block diagram of a pulse radar system. In this we have pulse modulator, transmitter, duplexer, low noise RF amplifier, mixer, local oscillator, IF amplifier, detector, video amplifier and display. By using the pulse modulator, we can generate the pulse modulated signal, and this pulse modulated signal is applied to the transmitter. By using the transmitting antenna, we can transmit the pulse modulated signals into the space, and these signals are train of a repetitive pulses or repetitive frequencies. Next one is duplexer. The duplexer means it is a microwave switch. It connects the antenna either to the transmission section or to the receiver section alternatively. If the duplexer connects the antenna to the transmission section, then it transmits the electromagnetic waves or pulse modulated waves into the space. If the duplexer connects the antenna to the receiver section, then it receives the echo signal from the space. So the antenna transmits the pulse modulated signal. With the duplexer connect the antenna to the transmitter. Similarly, the signal which is received by the antenna will be given to the low noise RF amplifier. When the duplexer connects the antenna to low noise RF amplifier, the low noise RF amplifier it amplifies the weak signal which is received from the duplexer. Means these signals are received from the target. Next one is local oscillator. The oscillator means without giving any input, by using the oscillator circuit we can generate the signal. So it produces the signal having the stable frequency. The output of the local oscillator is connected to the mixer. So here we are having the two inputs to the mixer, and the first one is the output of the local oscillator and the output of the low noise RF amplifier. So the mixer can produce the both sum and difference of the frequencies which is applied to it, among which the difference of the frequency will be considered as intermediate frequency, that is IF frequency type. This IF frequency is applied to the IF amplifier. The IF amplifier amplifies the intermediate frequency only. The IF amplifier is shown in the figure, allows only the intermediate frequency signals only which is obtained from the mixer and amplifies it. So after amplification we can easily improve the signal to noise ratio of the signal. Detector means demodulation process. It demodulates the signal which is obtained at the output of the IF amplifier. Next one is video amplifier. As the name suggests, it amplifies the video signal which is received from the detector. After video amplification, this amplified signal is given to the display unit. By using the display unit, we can easily find out the distance of the target and range of the target and the directions of the target. And the next one is advantages of the pulse radar. The first advantage is precise range measurement. The pulse radar can directly measure the distance to a target by calculating the time of flight of individual pulses. And second advantage is high peak power, because the energy is concentrated into short bursts rather than the emitted continuously. The pulse radar can achieve very high peak power levels. This enables long range detection of the distant targets. Next, third advantage is single antenna operation. By using in pulse radar, we are using only single antenna for both transmission purpose and the receiver purpose. So the system transmits a pulse, then switches to the listen mode to receive the echo, saving on space and hardware cost. And the fourth advantage is multiple target tracking. By using the pulse radar, we can track the multiple targets. Next, all weather reliability. The pulse radar remains effective in rain, darkness, and fog, which often compromise the optical systems. And the next is disadvantages of the pulse radar. The first disadvantage of the pulse radar is minimum range or blind zones. The pulse radar cannot receive the echoes while it is transmitting. If a target is too close, its echo will return while the transmitter is still active, the making it is invisible to the radar. And next one is range ambiguity. If the pulse repetition frequency is too high, an echo from a distant target may return after a second pulse has already been sent. This creates second time around echoes that appear at incorrect and much closer ranges. Third disadvantage is clutter interference. The reflections from the ground, sea, or weather can mask the smaller targets. While pulse radar techniques help filter this, they add significant system complexity. Fourth disadvantage of the pulse radar is that high complexity and cost. Designing and maintaining of the pulse radar is very complexity and cost is also high. Vulnerability to jamming. Because they emit high power pulses, these systems can be easier to detect and target with electronic countermeasure or jamming. The applications of the pulse radar systems are military surveillance and defense, air traffic control, weather monitoring, marine navigations, remote sensing and mapping, speed detection, space and satellite tracking, search and rescue operations, ground mapping and geological studies. Next one is continuous wave radar. In pulse radar, we used only single antenna for both transmission purpose as well as for reception purpose. But in continuous wave radar, we are using the separate antennas for some transmission purpose and separate antenna for reception purpose. The continuous wave radar means the radar which operates with the continuous waves to detecting the non-stationary objects is called the continuous wave radar. The radar requires two antennas, among which one antenna is used for transmitting the signal and another antenna is used for the receiving the signal. And this block diagram shows the block diagram of the continuous wave radar. In this we have continuous wave transmitter, mixer 1, local oscillator, sideband filter and mixer 2, IF amplifier, detector, Doppler amplifier and indicator. The continuous wave transmitter means it produces the analog signal and frequency of the F0. The output of the continuous wave transmitter is connected to the both transmitting as well as for mixer 1. By using the transmitting antenna, we can transmit these continuous waves into the space. The local oscillator. The local oscillator, it produces a signal having a frequency of the FL and the output of the local oscillator is connected to the mixer 1. So here we are having the two inputs to the mixer 1. They are output of the local oscillator and the output of the continuous wave transmitter. The output of the continuous wave transmitter means the signals are transmitted by the continuous wave transmitter. So the mixer 1 means it can produce the both sum and difference of the frequencies that are applied to it. The signals having the frequencies of F0 and FL that are applied to the mixer 1 and it will produces the output having the frequencies of F0 plus FL. Next one is sideband filter. We are having two sidebands. They are upper sideband frequencies and lower sideband frequencies. By using the sideband filter, the sideband filter allows the particular sideband of frequencies only, either upper sideband frequencies or lower sideband frequencies. The sideband filter shown in the above figure produces only the upper sideband frequency only, that is F0 plus FL. And the mixer 2 also the produce the both sum and difference of the frequencies that are applied to it. The another input to the mixer 2 is the echo signal. The echo signal means it is received by the receiving antenna from the space. The frequencies of the echo signal is the FD. The FD means Doppler frequency. So the another input of the mixer 2 is the echo signal. So the mixer can produce the both sum and difference of the frequencies that are applied to it. The signals are having the frequencies of F0 plus FL, and F0 plus or minus FD are applied to the mixer 2. So the mixer 2 will produce the output of frequencies having 2 F0 plus FL plus or minus 2 FD. IF amplifier, it amplifies the intermediate frequency only, that is produced by the mixer 2. Next one is detectors. It detects the signal which is having the Doppler frequency of the FD. Doppler amplifier, as the name suggests, the Doppler amplifier amplifies the signal which is having the Doppler frequency of the FD. Indicator means it indicates the information related to the velocity and whether the target is inbound or out of the bound. The continuous wave radar gives accurate measurement of relative velocities. Hence, these are used mostly where the information of velocity is more important than the actual range. Next, the advantages of the continuous wave radar is that high velocity accuracy. The continuous wave radar is excellent at detecting small changes in target speed via the Doppler effect. The simple and low cost. The designing of the continuous wave radar is simple and the designing cost also low. No range limitations because the transmitter is not turned off to listen for echoes. It does not have the minimum range limitations of the pulse radar. Efficient for close targets. It is suitable for short range applications like police speed guns or traffic sensors. No stationary clutter, generally ignores the stationary objects and focusing on only the moving targets. Disadvantages of the continuous wave radar. No range information. The primary drawback of the unmodulated continuous wave radar is that it cannot determine the how far away the target is. The transmitter or receiver isolation issues. Since the transmitter is always on, leakage can enter the receiver, limiting overall sensitivity and range. Multi-target confusion. It struggles to differentiate between multiple moving targets. The limited long range, the maximum power is low, restricting its effectiveness over long distances. And the applications of the continuous wave radar are speed measurement, Doppler weather radar, missile guidance and systems, aircraft navigations and collision avoidance, motion detection systems, military target detection, sports and speed measurements, industrial application. The main difference between the continuous wave radar and pulse radar is that the pulse radar is determined only non-stationary objects only, while the continuous wave radar is detecting non-stationary objects. And in pulse radar we are using only single transmitter, so single antenna for transmission purpose and the receiver purpose, but in continuous wave radar we are using the separate antennas for transmission purpose as well as for the receiver purpose. Thank you. In next class we are going to discuss about the Doppler radar systems and monopulse radar systems.